Okay, we go on to the next question. A spherical mirror have a focal length of 10 centimeter. Okay, so for mirror, if the focal length is 10 centimeter, positive 10 centimeter, it shows that this is a concave mirror. Okay, this is a concave mirror. Find the position of the image if the distance of the object from the mirror is 5 centimeter. So U is 5 centimeter. Right? So we use 1 over F equal to 1 over U plus 1 over V. We use this formula. We plug in all the value. 1 over 10 equal to 1 over 5 plus 1 over V. Okay, use your calculator and find the answer. So 1 over 10 minus 1 over 5 is negative 10. Or negative 1 over 10. So my V is negative 10 centimeter. Okay. If negative answer, it shows that the image is located at the opposite side of object. Okay. For negative answer, the image is located at the opposite side of object. Opposite side of object. Okay. Now, and then they ask you to find the magnification. So magnification is equal to negative V over U. Okay, negative V over U. So my V is negative 10. So it's negative 10 over U. U is 5. Right. So 10 divided by 5 is 2. Okay, 2. You get a positive answer. Positive answer shows that this is an upright. Okay, the image is upright. And then the value is greater than 1. So it's meaning that the image is being magnified. Okay, so the image is magnified. For upright image is always virtual. Okay, for upright image is always virtual. So these are the characteristics of the image form. Upright, magnify, virtual, and the image is located at the opposite side of the object. And then they ask you to illustrate each answer with a ray diagram. And as usual, if you want to draw a ray diagram, it's better for you to use a ruler and you do a scale. Okay, let's say 1 centimeter is equal to 10 centimeter. Right? You use a scale to draw. You use a ruler and the scale to draw your ray diagram. But as usual, I'm not going to use any ruler here. So I just draw it roughly. So I have my central axis, and this is a concave mirror. So this is how a concave mirror looks like. This is my center. Okay, my focal point is 10 centimeter. So roughly about here, this is my focal point, and my object is located 5 centimeter. Let's say here, this is 5 centimeter. Okay, so this is my object. Right. So the first step, the first ray is that I'm going to draw a ray that is parallel with the central axis. A ray that is parallel to the central axis will be reflected back through the focal point. Okay, that's the first step. And then the second step is that a ray that is from the focal point or passes through the focal point and being reflected, will be reflected parallel with the central axis. Okay, meaning that let's say I have a ray from the focal point here that passes through the focal point. It will be reflected back parallel with the central axis. Okay, so this ray like come from the focal point. Okay, and then it will be reflected back parallel with the central axis. And you see, these two rays won't intersect. Okay, if you draw also, it won't intersect. So we extend the ray behind. Okay, this is my first ray just now. So I extend it behind, and Since behind the mirror, it will be a virtual image. Okay, virtual image, so I use a dotted line. For virtual image, use a dotted line. And this one also, I will extend my line behind the mirror. So use a dotted line. And this is the point of intersection. Okay, so this is my image. Okay, and this is virtual, virtual image, because it's behind the mirror. Okay, it's behind the mirror, and we can verify our diagram with the calculation. You see that you get negative answer, meaning that the image is located at the opposite side of the object. So here's the object, here is the image, opposite side. It's upright, it's magnified, and it's virtual. Okay, so that's how we do it.